Here's some food for thought. I've got some code over here. 3 things, 2 declarations. A is 6, B is 10. And then this. Seems a bit tricky. Why would I put this? Can I put this on a line by itself? So by this point in the course, you should know that just running A plus B doesn't change anything. It computes a value, but on this line, I don't even use it for anything. I just have an expression sitting on a line by itself. So what happens here? Well, if I hit a line like this is a ridiculous thing to write because it actually does nothing. When I hit a line like this, we compute the expression. So 6 plus 10. Okay, so the result is going to be, let's see, I guess it'll be 16. And then we just throw that away. And that's what happens. You can put an expression on a line by itself, and the expression gets computed, and then whatever the result of the expression is gets thrown away. No big deal. And it turns out all semester we've actually been doing that, because it turns out that whenever I write an assignment statement, something like this, the reason that the variable a gets modified is because this is actually an expression and the equal sign is an operator. But it turns out that because the equal sign is an operator, I can stick assignment expressions inside of other expressions. And so it's weird to just put a plus b on a line by itself. But really what I'm doing is taking advantage of the fact that in C, I'm allowed to put an expression on a line by itself all I want. And those assignment statements that we've been writing all along are really just regular expressions sitting on a line that happen to use the assignment operator. And the assignment operator both does a job, that is, it sets, in this case, Z to be a value, but it also produces some other value, just like any other operator. And so I'm allowed to write really weird looking things like this. Z equals 5 times and then an assignment. And so what we have to think about is not only what does the assignment operator do on the side, I mean in this case this assignment operator sets a to a value, but if I use the assignment operator like I would use any other operator in an expression, what is produced as the result? So let's start with the basic assignment operator. So the basic assignment operator looks sort of like this. The thing on the left has to refer in some way to a variable. So for example, here it's a variable called a. And the thing on the right is, well, I don't know, some expression. Who cares? It's some expression. We already know how to work with assignment statements and assignment operators in that sense. We evaluate what's on the right, and then we assign it to what's on the left. But the question is, if I use the assignment operator inside of a bigger expression, what comes out? So if I were to write something like Z equals this whole thing, what comes out of the brackets? And the answer is, the result type is whatever the type of A is. So and the result value is the new value of A. In other words, I do the assignment just like I'm used to, and then whatever the new value of A is, that is what gets sent out of the brackets. That is the result of my assignment operator. And you'll notice, of course, there is the side effect that, of course, I update the value of A. So let's take a look at this. Here we have Z equals 2 times this assignment statement. We know, of course, we have to do what's in the brackets first. We also already know the rules for assignments, which is that the right-hand side has to be handled before I even look at the left-hand side. Okay, so let's evaluate the right-hand side. I've got int plus int. And so I know that on the right-hand side, the result is going to be an int. The value of b is actually 10, so 10 plus 7. I'm going to get the value 17. And it's important, I think, when we work with assignments that appear in expressions to actually draw this out as a diagram, because it's not just the value of z that I'm going to care about. I could modify a or b in the process of using the assignment operator. So maybe it's better to start like this. Okay, so a is 6, b is 10. I got to this point. So now I take the value 17 and I put it in my variable a. That's the side effect of the assignment operator. The one that we rely on. We use that one a lot, but it's just a side effect. And so what comes out of the brackets? The value that comes out is whatever my new value of a is, in this case 17. And the type that comes out is the type of a. Even if whatever I assigned to a wasn't an int, the type that comes out will be an int. So now I have z equals 2 times 17, and that means z gets the int value 34. Okay, so what about this example? Here, I have deliberately used a mixture of different types. So we'll start as before by drawing ourselves out a little diagram here. And this time, both b and z are doubles. And the goal is to make this a bit of a trick question. We'll see in a minute that because b is a double, the division a divided by b gives us 0.6, which is sort of nice. Usually we're expecting integer division shenanigans when we see something like this. But because of the strange way that the assignment operator works, the advantage we get by getting 0.6 is erased because the assignment operator converts the result back to an int. So let's go through it. So here I have int divided by double. And we know that the result that comes out of that will be a double. All right. And then the actual value would be 6 divided by 10.0. I should have been more clear about that it's a double value in b on my diagram. Okay, so this is a double, so I will get 0.6. Okay, all good so far. But now I assign this to a. And if I assign 0.6 to a is an int, which means all a can contain is the integer part of that, or 0. And because the value that comes out of the assignment operator is the new value of a, which is 0, the result is going to be 0. So even though what I had in here was in fact a double, 0.6, because I'm using the assignment operator in the meantime, what comes out ends up being an int. And so the result for z is just going to be 0. Then there are these. So we've seen already the various shorthand assignment operators, the ones of the form a plus equals, minus equals, multiplication equals, division equals, and modulo equals. And these are identical to the long form version. We can expand out each short form assignment operator on this page to the thing on the right. And that means if you ever see them inside some other expression and you want to evaluate them, what you could do is just whenever you see this, sub in one of these and then go forward just like we did in the previous examples. And so I'll show that off. B plus equals A. So I rewrite this as B equals B plus A. And one quick note about these shorthand operators. The shorthand operator always corresponds to the case where, so A plus equals is always going to be a case where we have A equals A plus. The variable will always appear on the left-hand side of the operation. There is no shorthand for the opposite version. So for example, there is no shorthand for operations of the form A equals, 6 minus A. We have to write that out in long form. But if I have a equals a minus 6, that is exactly equivalent to a minus equals 6. All right, so back over here. I just cross out the shorthand and I write in the long form version. And now I just evaluate this like I was before. So there's a, there's b, and there's z. And they are all ints again. A is 6, B is 10, and now I go through this. So B equals B plus A. Well, I do the right-hand side first, so B is 10 plus 6, and so the type of this will be int plus int, which is int, and the value will be 16. So I set B to have the value 16. What comes out of the assignment operator is the new value of b, which is 16, and the type will be the type of b, which is int, and so the value I end up getting in z will be 16 times 2, or 32. Here's another example. This is pushing it a little bit further. It's not that much different. It's just using more assignments. So we rewrite this as a equals a plus 2, and b equals b minus 2. We draw out our diagram. And then a is 6 and b is 10. Okay, so we'll run through this. B equals b minus 2. Maybe you can convince yourself in this example, it's relatively obvious that I'm going to have int all the way through. So here I'm not going to draw that out. On a midterm question, even if it looks obvious, you probably still want to draw it out just in case it's a trick. So we have b equals 10 minus 2, a equals 6 plus 2. So the new value of a ends up being 8. The new value of b ends up being 8. And so we assign to a the value of 8. We assign to b also the value of 8. And what comes out of the brackets in each case is the new value of each variable, so 8 and 8. And so z ends up with the value 64. And the key thing to understand is that at this point in the code, this one statement modified 3 of my variables. And that means I need to be keeping track. And if I try to do this in my head, just like before, I can brag. The diagram does help keep my thoughts in order because there's a lot going on. And unfortunately, it's about to get a little bit worse. So we've got these shorthands as well. And fortunately for us, these shorthands are a bit on the easier side compared to the other ones. We already saw that there is a shorthand plus plus a, but there's also this, a plus plus. This is only talking about the former case. So plus plus a is actually called pre-increment. This is the pre-increment operator. This is the pre-decrement operator. And it turns out that these are exactly equivalent to certain shorthand assignment statements. And those in turn are exactly equivalent to regular assignment statements. A equals A plus 1, A equals A minus 1. And so what do we do? Well, the result that comes out of using this expression is the new value of A after you have incremented or decremented it. So this adds 1 to A and sends back the new value of A. And the type that you get is whatever the type of A is. So it's equivalent to running one of these things. Okay, so that's one thing. On the other hand, then there's this. So we also have this other incrementation shorthand operator, A++. And we've seen for the uses that we've had for it already, it doesn't seem that different. But then why are there two operators? And the reason is because if you ever employ these operators in an expression, so up until this point, we've just used A++ or I++ on a line by itself, where nobody ever cares what happens if I take what comes out of the operator. Nobody cares about that, so we've never noticed the difference. But there is a difference. In our pre-increment operator, we add 1 to A for here, and we send back the new value of A. For post-increment, we add 1 to A and send back the old value of A. So A still gets modified, but what comes out of the expression is the old value before you increment it. Hopefully you're watching this and you're saying, what the hell is going on? Why would you add something this confusing? It makes no sense. It makes no difference. And I'm sort of with you. But it turns out, we'll see later in the course, late October, I think, maybe November, we will see a point where this operator just makes our lives so much easier. It's weird, it's hard to get used to, but it actually turns out it can really help. There is a time when we want to both increment a variable and remember the old value of that variable. And this is a rare case where I can't easily prove to you that we really need to know this difference just yet. We do need to learn it now because it's going to be too much if we have to learn it at the same time we learn some of that later stuff. This is just something to put in our back pocket while we're learning about operators. All right, let's try out some of these things. Z equals A++ times B. So we'll draw ourselves a diagram. And I should also observe, unlike the pre-increment, where we saw already that the pre-increment operator plus plus A is equivalent to A plus equals 1, which is equivalent to A equals A plus 1. The post-increment operators aren't equivalent to any specific regular assignment statement. They really are a class of their own. There is a way of getting the same effect using a bunch of other operators, but not directly equivalent to one assignment operator. All right, so we're back here. We're drawing our diagram. There's A, there's B, and here's Z. It's a pretty ridiculous looking box. Got 6, got 10. Let's evaluate this. So A++. This expression evaluates to the type of A, okay, so that's int, and it has the effect of incrementing A, and the value it sends out is the old value of A, so the current value of 6, and then we remember to increment A. So now it's 7. Okay, and the value of B here is 10, and its type is also int, and so we have int times int, that's int, and the result that goes into Z is 6 times 10, or 60, and there we have it. Let's take a look at this example. Plus plus A times B. I got to redraw the whole diagram. This is lots of fun. I'm having lots of practice drawing diagrams today. And here we have A is 6, B is 10, and what is Z? So plus plus A. The type is int. The type is B. The type of B is also int. We'll save that for later. And plus plus A says add 1 to A, send back the new value of A. So we'll add 1 to A first. That's why we call it pre-increment. Increment before sending out the result. So A is now 7, and the result is 7, and B is 10, and so what goes into Z eventually is 70. Here's this, and you can see there is quite a massive opportunity for me to write incredibly ugly and confusing looking expressions, especially if I get rid of all of these brackets. So we don't need brackets here. And we can make things look really ugly if we get rid of the brackets, because we can end up, and we'll see one in a minute, we can end up with some really strange looking stuff. So we'll reconstruct our diagram. We've got the widescreen version of B and not C, Z. There we go. 6 and 10. Okay, minus A. This is pre-decrement. We subtract 1 from A and then send back the new value of A. So in this case, we subtract 1 from A. That brings it to 5. The value that comes out is 5, and it is an int. So, and this is the post-decrement. Subtract 1 from B, but send back the old value of B. So B will change to 9, but the old value was 10. And so it's also an int. And so we end up with 5 times 10, and that's int times int, which is an int. And 5 times 10 is 50. And so Z gets the value 50. And then there's this. And maybe you see what I was talking about now. A++ plus B. That's valid. That is valid C code. We can write that. If we put it in some brackets, it would look a bit better. But we can write it just like this. All right. So we've got int A, it's 6. We'll start out in high spirits. We'll just hope for the best. B is 10. And then here's Z. Let's see if we can work this out. So in this case, we'll see next week. So a question like this could show up on the midterm, but we'll talk next week about what do you do if there are no brackets? Which operation goes first? It may be sort of obvious that you can't do this plus until you've done this stuff. So the brackets, actually, the implicit brackets do show up here. But let's go through this anyway. So we'll see next week ways to know where the brackets would go if you don't have any brackets at all. Okay, A++. Add 1 to A, send back the old value of A. So the type is going to be int. If we send back the old value, it's going to be 6, and then I add 1 to A. Okay, now it's 7. Plus B, well, that's going to be an int. Add 1 to B, send back the new value of B. So I'll add 1 to B, so it was 10, it's going to become 11, and now its value is 11, and then we have 6 plus 11, int plus int. We've got int plus int equals int. 6 plus 11 equals 17, and so Z gets the value 17. And so we've concluded our tour, our scenic tour of all the different assignment operators, the regular original recipe assignment operator, the shorthand ones, plus equals, minus equals, and even the strange pre-increment and post-increment operators. And remember that most of the uses that we have for things like A++ don't really depend on whether we add 1 before or after sending back the value, because we often use them for things like incrementing a loop counter. But it's important that we know the difference between those two things, because there will be places where we do need one or the other.